Kia ora koutou. This is the first video I'm doing this year for the Level 3 Calc papers, and this one is an integration one that I think was pretty unpopular. I just want to say a huge shout out to the NCEA memes page on Instagram though, and I have put in one of your memes. I think I meant to do that. Apparently memes are meant to be shared. If you want me to take this out, I can totally take this out and I'll redo the video. So just let me know, just send me an email or leave me a message on the video saying get rid of the meme. Anyway, here's the meme. And this video is going to be about the question that was all about sine cubed of 2x times cos cubed of 2x. So this is, I'm pretty sure this is an excellence question. I guess the really boring thing to say to you all is that if you're looking at this for next year's exam, you have to do so much practice at trig integration. Like when you think you've done enough, go and find another set of trig integrals to practice on with all the patterns in coefficients and the trig functions, and just lots and lots of work on these, because if you see the patterns, these are really not that hard. And I know that that's not what lots of you want to hear when you've just struggled through this exam. So I'm really sorry about that. So good places to look for those questions are in the amazing Delta textbook. And if you're at Wellington College or other schools, then Mr. Black's new Level 3 textbook is a great one as well. Okay, so here's my graph, and we're told the limits of integration, and we're told to find the shaded area under the curve. So it doesn't get much more straightforward, except that the integration is a little bit tricky. So here's the meme, and now here's how we do the problem. So let's just start out by having a look at what we've got. Well, we've got the integral between pi on 2 and 0 of sine cubed x times cos cubed of x dx. Now we really don't like working with a product, but hopefully most of you spotted pretty easily that we have something going on in here with a sine of 2x in here. So we can rewrite this going quite slowly as sine of x cos of x cubed dx. And that expression is equal to a half of sine 2x cubed dx. So now we can pull the constant out the front. We're going to pull 1/8 out here. We get 1/8 times this integral. It's going to be sine cubed of 2x dx. But if you're looking at that, you know that we can't simply go sine to the power of 4 2x times 1/8, because when we differentiate this, we're going to get a cosine 2x because of the chain rule. Okay, so that's not going to work. So we have to think about how we can split this up to get a pattern where we've got something with a cosine blah blah and then a sine to the power of something, and then that would work out nicely. And the best way to do that is to split this up into a sine of 2x. I'll just get some more room. So we split this into, where's it gone? Hang on. So we've got 1/8 here, pi on 2 to 0 here. And we're going to split this into sine of 2x times sine squared of 2x dx. The reason we want to do this is that this is going to be the link through to cosine. So now we have 1/8 the integral from pi on 2 to 0 sine 2x times 1 minus cos squared 2x dx. And we can expand out those brackets, and now nearly all the hard work is done. Oops. So we have sine of 2x minus sine 2x cos squared of 2x dx. Finally, we're ready to integrate. So we get equals 1/8. We're going to leave a gap for the coefficients. If you're in my class, you're kind of used to me doing that. I think most of us probably do that. So leave gap, we're going to have cosine of 2x. When I differentiate that, I get negative sine. I don't want a negative, undo the negative, and I also get a 2 that I don't want. So it's going to be negative 1/2 cos of 2x. Leave another gap. We're going to have something with a cos cubed of 2x. Now when I differentiate that, I'll get a 3 coming down. So we don't want the 3 up here. And we'll get a 2 coming out of the 2x. We don't want the 2. And we will get a negative sign, and we do want the negative sign. So we're going to have this, and now we're ready to finish it off and hopefully get a nice number. Now cos of 2x will be cos of pi and cos of pi is equal to -1, and cos of 2 times 0 will be cos of 0, which is 1. So just pop that out there. We get equals 1/8 of -1/2 times -1 plus 1/6 times -1 cubed minus -1/2 times 1 plus 1/6 times 1. And you'll notice there's some nice symmetry stuff going on in here. And when we look at the graph in a second, you'll see what's happening. So we've got 1/2 minus 1/6 plus 1/2 minus 1/6. Right, so that's what I mean about the symmetrical stuff that's happening. You don't have to notice that to do this question, so don't worry about it too much. We've got 1/8 of 1 minus 1/3, which is 1/8 2/3, giving us a final answer of 1/12. Now I've got that done in GeoGebra. I'm going to show you that graph now. So this is just a screenshot, but this is the function y is equal to sine cubed x cos cubed of x, and you can see that we want the integral between 0 and pi on 2, and it does indeed equal 1/12. Now interestingly, I checked when I was going to do the GeoGebra thing, I typed the function in to Google and it gave me all the AI crap, and the first AI answer was wrong, which was pretty funny. So AI got an answer of 1/24, then it did the question twice and it went, oh, I'm really sorry, I got it wrong. So like definitely use AI to learn if it's going to help you, but make sure that you're actually having a go at working through every single step of the question, because that's how you're going to get the most out of it. Okay, that's the end of the little AI speech for today. I hope that was useful. If there are any particular excellence videos you want done before the other ones, just leave me a comment and I'll try and get to those in the next couple of days. Thanks for watching.